Hey everyone, it's Linden, and I'm here to solve problem 10 from the sprint round of test 12311, which reads, a perfect spherical chocolate-covered macadamia nut has a radius of 10 millimeters. The macadamia nut inside is also perfectly spherical with a radius of 8 millimeters, and the rest of the chocolate-covered macadamia nut consists of chocolate, which we will then melt to form a separate sphere. So to the nearest whole number, the question is, how many millimeters is the radius of this newly formed sphere of chocolate? And you can sort of think about this problem by drawing your nut, which we can represent with maybe a little circle, and then we have our chocolate that we can fill in. And inside this nut, we have inside this chocolate, we have this inner macadamia nut, and its radius is going to be 8 millimeters, where this big one's going to have radius 10 millimeters. And essentially, we want to find the volume of this, the chocolate that's not the macadamia nut, meaning we want to find the difference between the volumes of these two spheres, the entire thing minus the volume of the macadamia nut. Now, recall that the formula for the volume of a sphere, any sphere, is going to be 4/3 times pi times radius cubed, where this radius is the radius of the sphere. So this smaller one's going to have sphere 8 and the bigger one's going to have sphere 10. And therefore, what we want to do if we want to find the volume of the chocolate, which we can then reform into a new sphere, we just have to take the difference of the volume of the sphere with radius 10 and the one with radius 8. And if we find the difference, we find that this is equal to 4/3 pi times 10 cubed minus 4/3 times pi times 8 cubed. And you can just use the distributive property on this difference, and you get 4/3 pi times 48. That's 10 cubed minus 8 cubed. And what we're asked is, to the nearest whole number, how many millimeters is the radius of the newly formed sphere of chocolate, which we know is going to have the same volume as this this chocolate that's outside of the macadamia nut. So this thing over here is going to be its volume, which means that in order to find the radius of the newly formed sphere of chocolate, you look at this formula, 4/3 pi r cubed, and we see that the volume of this newly formed sphere of chocolate is this thing, and therefore to find the radius, we just take the cube root of 488. 488. And you see that this is about 8. If you plug this into a calculator, it's a little less than 8. So our answer for the millimeters, the radius of the newly formed sphere of chocolate in millimeters, is 8 millimeters. That's it for this video. Thank you for watching, and we'll see you next time.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.